it's a high frequency discharge, okay? Low voltage, high frequency. What does that mean? Well, it's a high frequency, but it doesn't have much current, so it won't kill you, okay? So what we can do is, somewhere there should be something I can hold on to and won't get shocked here. The metal here. What about demonstration? Come on, Daisy. Come on down. Come on down. Yeah.
Oh my God.
I'm not going to do anything to you. I want you to tell this group what award you recently got and why did you get that award? Who gave you the award and what did you get it for?
I got a scholarship from the Armed Forces Electronics and Communications Association, and they gave it to me because I'm going to be a high school teacher doing demos, and it was to help me pay for college and stuff like that.
And the amount of money was?
$5,000.
$5,000. We're still trying to. I looked at this knife before I did that, and I saw that the metal only came halfway down, and I was holding it down here, and that thing bit me. Okay, that's why I got It's an amazing little device. Most of us don't have a chance to play with it. Every time I do it, I have to touch it. I have to touch it. You're a fool. No, I'm not a fool. It's just you just have to dial it down a little low. Did you get it slow?
Mm-hmm. Yeah.
A little bit. You can hear it? I thought I could, but I thought it was my age. Oh, say it now. Yeah. Okay, so I got to touch. You got to do it. Of course, it comes down afterwards. You can check it out. It costs $1, but I got to pay. So we've got the nails in here. I'm trying to see how they're lined up. They're pretty good. And Dr. Kevin has done what I asked him. He's filled it with water and poured it out so fresh air has been sucked in. Now we're going to, so that's pretty good. Now we need the fuel. Now you'd be using octane, gasoline, but we're going to be using the simplest of all the alcohol, methyl alcohol, methanol. That's going to be a fuel. We can use gasoline, but methanol is a little more controlled. Okay, so I'm going to squirt this in. You don't need much.
Oh, yeah.
Ooh.
Shit's gonna fall up.
I got this. I put a little stopper on.
Oh, boy.
Why are you backing up? Oh, no, but you're backing up. After the knife So now what we've still got a little methanol liquid in the bottom here. But now, because I've shaken it up and it has a vapor pressure, there's methanol vapor all up in here in the airspace, the free space there. And it's got these two little nails sticking in. Now I'm going to take that tester coil and touch it to one of the nails, and that's going to cause a spark to jump between the two, and that's going to explode the methyl alcohol vapor. That's what's happening in your engine that many times, okay? That's the chemical reaction. You're going to see almost see what's happening in your spark plug in your engine. Okay.
You think?
Just to make Did everyone sign the waiver form? Kevin, did you pass that out?
Oh, yeah. Oh, yeah.
That's so
I want to see that. I want to see that again. Okay. Walk on a little tighter. Stop it on a little tighter. Hit it again. Nothing. Chemistry. When the first explosion occurred, that burned up all the oxygen that was in the air that we got. Turned to carbon dioxide. There's nothing to combust now. The methanol is still there, but there's no oxygen to combust. Isn't that neat? And what happened when I sent the fellow, he just, I said, rinse it out, so he just put a little water in, rinsed it, didn't fill it all the way up, so we get a full charge of air. So that's what's happening in your inside your engine, the internal combustion engine with a spark plug. That's how she's working. Sparking the octanol gasoline vapor. Okay, well, that's good. Now, when I said about live, I did this experiment a couple times. I didn't come to teach general chemistry until later, so I wasn't familiar with this, but till late in my career. So I was doing this, and I thought that would be pretty neat. And I happened to be in a lecture room that had one of those little lecture, what do you call it? Or whatever those platforms are. Huh? Well, it was kind of a simple one, just a piece of wood going down at an angle. And I looked out on this tiered 200-seat auditorium, and I said, okay, today we're going to do this experiment a little bit different. Just a little different. I'm going to put the bottle on the platform, and the cork stopper is going to go out over top of the audience, huh? Wouldn't that be neat all the way across the lecture room, okay? Because the time before that, I'd put a dent in the new ceiling when this boom went up. I didn't see where it went today. So, everything just like you've seen, okay? But instead of doing it on a flat desktop, now I've got it angled, okay? I didn't even think about it. That could have put out somebody's eye. I mean, it's not a rifle. I can't line this thing up. I just pointed it up. It's going to go out there. Yeah, right. Fortunately, it did go up there. But as Newton's first or second law says, for every action, there's a reaction. And the reaction was to send this thing back toward the wall, toward me. Spilling alcohol was caught on fire. I've got a fire. I'm surrounded by fire. Students are yelling and screaming. Cork went came to the back of the room, and they're now cheering. They break into cheering. You can't get that kind of excitement or unpredictability. And that's half what a demonstration is unpredictability. Let's see what the professor's going to screw up this time.